Hi everybody, so this is problem set 52, and this is more on how to add rational expressions. And this is different than the last time that you've done this because this time we have unequal denominators. Another kind of bonus topic is overall average, where we're going to be looking at averages of two sets of values and figuring out how we can figure out the average of those two sets combined. So let's take a look at this first example, and you notice we have two rational expressions here that we're trying to add together. We have a over x plus b over x plus y, and one of the things to notice first and foremost is that they do have different denominators. So what we have to do is we have to find a common denominator before we can add these together. This is a very similar concept to how we add fractions. So the way that we're going to do that is we're going to figure out the LCM of those two denominators. And so the LCM, or I should say least common denominator, in this context, is going to be x times the quantity x plus y. And the reason that we know that is that together, when we multiply these each by each other, that's going to give us the common denominator. So now our job is to really change these so that they each have x times the quantity x plus y as their denominator. So I'm going to start with the a over x, and I have to multiply top and bottom by the quantity x plus y, so I'm going to do that. And so what I get when I do that is a times the quantity x plus y over x times the quantity x plus y. I'm going to do the same thing with b over x plus y. This time, because we want the denominator to be x times the quantity x plus y, we need to multiply top and bottom by x. And when we do that, we end up with bx over x times the quantity x plus y, remembering that we're multiplying x times this entire thing, which is why I say times the quantity. So now if we kind of go back to our original expression here, we're adding these together. We're taking a times the quantity x plus y over x times the quantity x plus y, and we are adding it to bx over x times the quantity x plus y. And just like we would do with fractions, we're going to add the numerators. And so what we get, because we definitely don't have any like terms up here, is a times the quantity x plus y plus bx all over x times the quantity x plus y. And that would be our final answer for this one. All right, so let's take a look at this one down here. It's a little bit more complicated. There we go. Still getting used to this thing. This time we actually have three rational expressions here. A over b plus c, x over k, and d plus m over k. And again, we're trying to find the LCM of these three. And because these have the same, these are both k's, we're really going to be able to just use one of them when we find the LCD. And so our LCD is going to be k times the quantity, b plus c. And so once again, we need to change all of these rational expressions so that they have this denominator. So that's going to involve multiplying them by what they need to be multiplied by, top and bottom. A over b plus c, we need to multiply top and bottom by k. So we end up with ak over k times the quantity b plus c. For x over k, well, we need to multiply this times b plus c if we want to have the same denominator. And we're going to do the same thing with the top. And so we get x times the quantity b plus c over k times the quantity b plus c. And then we have to do the same thing with d plus m, remembering that we're multiplying the entire d plus m over k times b plus c. And these are both quantities. I'm going to throw these in parentheses just so that we don't forget. And so what we end up with is the quantity d plus m times the quantity b plus c all over k times the quantity b plus c. And now really what we've done here is that we've got all three of these expressions with a common denominator. And so what we're going to do now is we're going to replace our new versions of each of these terms, 1, 2, 3, back into our original expression. So we get ak over k times the quantity b plus c. I'm not going to run out of room here. Minus k times the quantity b plus c all over k times the quantity b plus c. I guess I meant to say x times the quantity b plus c on top, plus the quantity d plus m times b plus c all over k times the quantity b plus c. And now it's just a matter of subtracting these, and this is going to be a little bit of a longer term, but here we go. So they all have the same denominator, so when we're adding these together, or subtracting them in this case, we can just do ak minus x times the quantity b plus c plus, I am going to run out of room, move over a little bit, d plus m times the quantity b plus c all over,
How you doing?
good, the quantity k times the quantity b plus c. And so there we have it. We can't combine any like terms, but we're there. And we've changed all of those to have common denominators. All right, so that's how to add or subtract rational expressions with unequal denominators. We change the denominators to be the same, just like we would with fractions. And then we add our numerators and group them over that common denominator that we found. Let's take a look at overall average here at the bottom. And this is kind of the extra part to this section. So it says the average of the first 90 numbers, I'm going to zoom in here just a little bit, is 4. The average of the next 10 numbers was 6. What was the overall average? And here we're given a little formula that says, yes, the overall average is the sum of all the numbers divided by the number of numbers. Now, because we know that the first 90 numbers have an average of 4, we know that the sum of those numbers is 90 times 4. And we know that because an average tells us kind of a redistribution of values. So if we have 90 numbers, we don't need to know what those numbers are. If we know they have an average of 4, we know that the sum of those numbers is that average times the number of numbers. We're going to take that and we're going to add it to the other set. So the next 10 numbers has an average of 6. So if it has an average of 6, that means that the sum of those 10 numbers is going to be 10 times 6, like so. And once we figure out the sum of the numbers, we're going to divide by the number of numbers. Well, there were 90 numbers in the first, there were 10 numbers in the second, so that means that we have 100 numbers total. So I'm just going to go ahead and simplify this. 90 times 40 is 360. 10 times 6 is 60. Leave that over 100. 360 times 60 is 420. Divide that by 100, and what we get is a total average of 4.2. So give this a shot. Try the problems out of your book on the next page.